Welcome back, guys. This is Yadi Kalsi here again. Today we are going to actually cover chapter number 2 for C7 California low voltage contractor certification exam. The chapter number 2 is actually more relevant chapter towards we have been talking about, or we will be talking about in the upcoming chapters. The chapter itself is actually named very correctly as Residential Structured Cabling System, which is RFCS. In this chapter, we are going to actually cover what exactly RFCS means. There are certain terminologies we will use, which is actually used in the field in order to design, install, implement, and manage the RFCS. I will just keep it short. I will keep calling it RFCS, so you guys should know by this time that it is Residential Structured Cabling System. We will talk about the grades of the residential systems. Then there are actually, what you can say is there are around 5 or 6 different terminologies, like for example, what is ADO, what is DD, or what is OC, or what is WO, or what is the telecom outlet, or some of these terms are actually will be covered, and I will try to cover as much as possible. Let's start. So let's first thing first, let's go through the technical definition of what exactly is a residential structured cabling system and cabling technologies, you can say. So the actual technical definition is an RFCS is defined as a complete collective configuration of cabling and associated hardware at a given site that has been installed to provide a comprehensive telecommunication infrastructure. So let's go it over go over this once again. So let's repeat it. And RFCS is what? Is a complete and collective. This thing we have covered in chapter number 1, but we will cover it more, what it actually means by it, of cabling and associated hardware. So there is a cabling, and then there is certain associated hardware also. Associated hardware, which we did not talk about in the previous chapter. So we will talk about that cabling. It's not only about the cabling now. They are also talking about something called associated hardware, which is a part of RFCS. To provide what? To provide a complete, comprehensive telecom infrastructure. So we can say a complete, end-to-end. Complete also means end-to-end, where they actually want you to work on infrastructure. So it is becoming bigger and bigger now, right? So an RFCS is a complete and comprehensive, it's a complete and comprehensive configuration. Configuration of what? Cabling and the associated hardware in order to provide what? A complete infrastructure, end-to-end infrastructure. So this is the complete technical definition of RFCS. So let's go over these terms, why they are calling it, so what are the terms are actually basically covered into this. And we will also talk about certain topologies. We'll talk about again about what are those standards, why we have to follow the standard, why cannot I just go and install the way I like at every home. So I have covered that into the previous chapters. So let's talk about why this standardization of RFCS cabling installation is required. Why? I think you should ask the question again and again, why? Why they're asking me to do follow a standard, right? So again, we are going with that 3 or 4 things we have already covered in the chapter. It is for the consistency of what? Design. So that I design the system of RFCS. When I go into a home, a single family home or MDU, I follow certain standards in order to design the network, right? Then there's a configuration of the physical infrastructure, which I follow. Configuration of the infrastructure. Configuration of this infrastructure is just a part of the design itself. How do I actually configure? Configure means, it doesn't mean that you have to log into something to actually configure configure something. Literally, it actually means how do you basically pull the cables, how do you put the racks together. So that is also part of the configuration now, right? Then There is a documentation behind it. Then we also follow like certain quality standards and components, which we talked about in the previous chapter. And then also there is a consistency for the testing and the labeling. I do my testing and labeling of the infrastructure so that it is easy, just in case if there is another contractor which is called in for, he should know actually what I have done. So why this RFCS is required, or why we are actually following the code and the law? It is for these multiple reasons: consistency of the design, configuration of the infrastructure is consistent, that the quality components are being used. They wanted to make sure that the testing and labeling has been done. And I have also used uniform documentation. I actually provide a documentation that this is what I have done through the part of labeling itself, or sometimes I might actually provide them a diagram also. That diagram could be kept with the owner, or you can keep a copy, or sometimes actually you will see that it is actually put it into like a kind of a waterproof package, and it is hung there in the telecom room itself. So I think before we actually go any further, I think let's talk about topologies. Very important topic. Topologies, topologies. Some people might say topologies, or topologies means the same thing. I might be pronouncing it a little different. I've learned it in a different way. So, but actually what it means, topology is basically again a way or a method in which certain things are done, right? It's a way or method in which certain things are done. So when you do an infrastructure installation, we actually follow certain standard for the designs also. So what it means by is there are certain topologies which you could follow, which were followed or which are now being followed. So we can say in order to run a cable, just to keep the conversation simple, we can call it daisy chaining or daisy chain. What is actually a daisy chain, right? Or we can say what is a bus installation, or we can say what is a star installation. So they might actually, you need to understand this through and through in order to understand the installation sometimes. What is meant by a daisy chain? So in the field you might see that 15 years back or 20 years back, the contractor who actually came into the home, he actually daisy chained all of the analog phones. So what exactly daisy chain means? If you don't understand what the daisy chain is, you might not be able to actually troubleshoot, or you might not be able to track the cables, why the phone systems are not working, or why the fax line is not working, and so on and so forth. In the bus configuration, where it is actually primarily used, what is the function of the bus structure, and what is the function of the star structure, we'll actually try to cover. So let's go with the daisy chaining a little bit. So daisy chaining is nothing but a series connection in the series, right? So what I do is imagine that I have a main point where some telecom. This is actually a telecom signal. Wherever you see in the drawing, this actually means telecom. Okay, telecom signal. So the service provider, let's call it access provider, they are calling here. Access provider provides a telephone cable. So they will actually come in a pair, right? Any pair of cable. Now you have a home here, right? In the home, you might have 3 floors. Floor 1, floor 2, floor 3, right? So, and you have 2 phones here. You have 2 phones here, and then you have 2 phones here. That is very much possible, right? If it's an 8-bedroom or 10-bedroom house or 6-bedroom house. So in this case, how would you actually connect through the daisy chaining? Using daisy chaining method or a topology here. That's what topology is, nothing but a method, right? So what you will do is you will run the cable to this guy. The same cable will run to this guy. The same cable will go to this guy. The same cable will go to this guy. The same cable will go to this guy. And the same cable will go to this guy. So what did you learn here? So what we learned is there is a source, right? We are using the hops like this, but the cable remains the same, right? If you guys know, when we draw a series circuit, so let's draw a series circuit in which we have a resistance 1 and resistance 2, resistance 1 and resistance 2, and they are connected by a battery, right? So this is what it's called series circuit. Series circuit. So what it means is, in case the cable is broken here, the whole of the circuit is actually broken. It means neither of this thing will work. So we can say it's a you can say a lamp here. So lamp 1 and lamp 2 will actually stop working, right? So this is the bad part of the daisy chaining, but the good part of the daisy chaining is you only use one length of the cable, and the installation is pretty simple. So the other thing is daisy chaining is also used was used in the computer networks before. We used to call it 10 base T networks, 10 BT networks, right? So what used to happen is we have computers, computer 1, computer 2, computer 3, and if you remember, I don't know if you guys have been in the computer field, but there used to be an Ethernet card here, and there was a T junction cable which actually goes from all of this. There was a T terminator here, but single cable will actually go to all of the one, like computer 1, computer 2, computer 3. In case this T is actually loose, the people who actually work in the field, if this T is loose, the signal will actually don't go to the other computer. So these two computers will be working, but this computer won't work. So that is again the problem of a daisy chaining. So there were some actually flaws in the daisy chaining, and we are using it less and less, right? What is a bus connection? The second is bus connection, right? So bus is nothing but a parallel, P-A-R-A-L-L-E-L, parallel connection. So in the parallel connection, what we do is, let's try to explain it. We have one lamp, then we have another lamp, right? All of these are actually powered by a battery. So lamp 1 and lamp 2. Imagine that there is a circuit break here, but the lamp 1 will still be working. So that is what actually it means. So in a telephone network, what you can, I will try to explain in the form of a telephone network, but it is not more relevant. But let's try to do that, right? So you have two cables coming here, and I have phone here, right? What if I run this cable like this, and the other cable like this, and the other cable like this, right? So in this case, if this cable is broken, only this telephone cable will actually go away, but this telephone will still be working. I will actually explain more. This bus technology is actually used in most of the CATV installation or CATV installation or satellite cable installations. Satellite cable installations. Let's try to cover the third topic, which is the most important these days. It's called star. Why this is called a star? So let's say I will actually just try to make a star here, just to keep it simple. Star will look like this. I will just, remove these like this to try to remember this as a star, right? And there is something in the middle. So I will try to simplify this diagram, but try to remember this as a star. So it's nothing but there is a central point of connectivity for all the things around it. So this could be a computer, 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 right? C1, C2, C3, C4. And this is what, let's try to learn more and more. This is called a network switch. In the books, if you are reading books, they might also say a network hub. Network hub. There is a difference between a hub and a switch, but don't get into the details of it. Start calling it network switch. So there is a difference between a switching and a hubbing or a hub. So no network hub is being used right now. It's an obsolete technology. The hubs are being replaced by the switch. Just as FYI, it is not a part of the exam. So what it means is every cable is independently connected into the center point, right? So if this breaks, only this connection goes away. If this breaks, it only this goes away. If this breaks, only this goes away. So, and also the expandability becomes like little easier. You want to put more computer, just run this cable. You want to put a more computer, you want to put one more computer, more computer, it becomes easy and easy. Star topologies, where it is used? Where it is used? It is used in modern day infrastructures, computer infrastructures or computer networks, and also telecom networks, especially when we use voice over IP. Okay, I will cover more this in the coming topics. So this was related to the topology. So we learned about that there are three types of topology. There are actually more. It's called hybrid star. In the hybrid star, you have two switches. There are computers connected like this. They might say we run a cable like this. It is, and we connect it like this. So this is called a hybrid star. This between the two stars, this is called the backbone cable, right? I will talk more about it. It's basically, you can remember backbone by something called SPINE. Spine cable. but this is hybrid star. So they might actually, you know, talk differently, but you need to remember only three. It's called the daisy chaining, it's called the bus, and the star topologies, right? Let's get into the meat and potatoes of actual RFCS. We need to learn what those terms are and you know, what they actually mean by it. So what I will do is I will try to first explain those terms, first put these terms, and then I will try to make a couple of diagrams, and we will actually go through that exercise of what these components are and where these components are used, right? It took me some time to basically think over it, how to explain you guys a little more easier. If you start reading the books, the things are everywhere and you cannot get it organized. So as per my personal opinion, I found out easy to remember, and so you can actually follow the same methodology, or you can actually follow something different which is easy for you to understand, but the topic remains the same. So let's go over the components or components of RFCS cabling infrastructure, right? So the very first component here is the distribution point. They call it DP. What is DP? It's called DISTRIBUTION, distribution point. Very, very important. I think you guys need to actually pay extra attention from now onwards, because it is getting into more and more details of the real work in the field. There's another term called ADO. What does ADO stand for? It's called auxiliary device. They have used actually different terms for it. It's called auxiliary disconnect outlet. Sorry, auxiliary disconnect. There is a reason they are calling it disconnect. Outlet means there is something which goes out of it. Outlet. They are talking about they're talking about another term called DD. DD, called distribution device, where it is actually used, the distribution device. And then they will talk about lot of cabling related to all of these. They will talk about the cabling about the DP, they will call about the cabling about ADOs, and they will talk about the cabling about the DDs. So what I did is I actually just put all of the cabling into one cabling platform. Cabling, so there are cabling related to DP, distribution points, distribution devices, they call auxiliary disconnect outlets, and you know, a couple of other different things which are actually related to that. They will also talk about patch cords. Again, I think in chapter 3 and 4 we are talking about patch cords. You guys can actually go to chapter 3 and 4 in order to understand more about patch cords. They will talk about the backbone cables. We talk about the backbone cables, so and so forth. So what I did is, in order to make it easy, I just put it all cabling into one cabling, because some or the other way these are standard cablings which we have discussed in chapter 3 and 4. So I would encourage you to go to chapter 3 first in order to understand those cabling, and then you can come back and you can understand this part of it. So where all of these components are used, again, distribution point, DP, ADO, auxiliary disconnect outlet, DD, distribution device, and then number 4 is a cabling. So all of this RFCS is no matter what is actually distributed into these sections. Sometimes the DP might not be used. Sometimes DP is actually used everywhere most of the time. ADOs could be ADOs and DDs could actually become one part depending on the size of the project. If it's a very small house, I don't honestly believe that you need to actually go through this whole hassle of putting this ADOs and DDs, and then there is a cabling infrastructure. So if you guys remember now, if you go back through the definition, the technical definition of RFCS, they were calling cabling and associated hardware. So what is this hardware? Now you will actually know that there is certain type of hardware which is actually required, or which is actually called the ADO portion, or DD hardware or DP hardware, right? So let's make a small diagram and try to interject or try to use these things there. What we will call what at what point in time, right? Let's make a simple diagram. Just try to follow me. So we will make a small home here. Let's keep it very simple. We can say floor 2 and floor 1. we will call this something. I'm not going to tell you right now, but this is something. Then there is something here, and there is something here. I will tell you what this something is, and there is something here. And then let's say there are in the floor you have rooms, right? So we can say room 1, room 2, room 3, room 4, room 5, room 6, room 7, room 8. So this is a pretty big actually installation that will actually help you understand all of these components. So we talked about, just as a reminder, we talked about DP, which is distribution point. We talked about ADO, auxiliary disconnect outlet. We talked about DD, distribution device, and then we talked about outlet cables, or for now you can say only outlet, or for now you can only say the cables, cabling part of it, right? And right now we will only say that, you know, just for the sake of example, just keep it very simple, that we are installing a telecom network. Let's keep it very simple, that we are installing something called a computer network, right? And which will be more relevant these days for you guys to actually work on it. So in this case, what is what? Let's go through that. So the very first thing is the DP. So where would be the DP, right? And it is actually most of the time